Good afternoon to you. Mark Sudduth, HurricaneTrack.com, here with your hurricane outlook and discussion. This is the afternoon edition. Going to be talking with Jack Sillin from weathermodels.com and the weather.us site. You know him from those awesome blogs with all the detail that we get about anything related to weather, especially big ticket weather events, such as what we have coming up here with PTC9, potential tropical cyclone number 9. If it does get named, of course, it will be the 9th name storm of the year, the I storm, and we'll work on pronouncing it when the time comes. So I'm putting this video together at 4:45 roughly Eastern time, and we're going to use the old Zoom. We're all familiar with the Zoom meetings now, thanks to good old COVID-19. But you know what? That allows us to do some amazing things. People like me getting to use it, and we bring in folks like Jack. There's Jack behind me. Are you still up in Maine? Yep, Jack's up in Maine. Kind of toasty up there.
Feels a whole lot more like North Carolina, though.
That's right. All right, so let's get right into it. The 5 o'clock advisory information, still a potential tropical cyclone. Air Force Reserve hurricane hunters have not closed off a low-pressure system with it just yet. A defined low-level center has not been detected. So it's still just PTC9, and we're going to talk about it. We're going to talk about what it looks like now, the future track, the intensity, potential here, pros and cons for what may or may not happen, kind of dig into this. And I think this is going to be really helpful. You know, like I said before in some of my videos, I don't know everything. And the day that I do know everything, it's time to start a new career, seriously. It's not challenging if you know everything. So I like bringing in people, even if I'm old enough to be their father, that can help expand all of our minds. All right, so there you go. So Jack, you've got the screen. What's happening with PTC number 9?
Yeah, thanks so much for having me, Mark. This is a really interesting system, and we'll start with a look at satellite imagery here. The system's convective appearance has improved markedly over the past 24 to 48 hours. So this time yesterday, the day before, we saw a few showers pop up with cloud tops down towards -50 or -60 Celsius. Now we have widespread thunderstorm activity pushing cloud tops to -70 or even -80 Celsius. So this system has really gotten its act together, and it will continue to organize as it moves off to the west-northwest rather. One other clue you can pick up in satellite imagery here about the system's overall status is the movement of its cirrus clouds. So you can sort of derive an upper-level wind field by sort of squinting hard enough at these cirrus clouds that you can see sort of wafting away from the center.
Right.
And when you see these cirrus clouds wafting away from the center in this sort of general clockwise rotation or anticyclonic rotation, that means the system has an upper-level high-pressure center nearly over top of it. And you can see we have cirrus clouds drifting off to the south on the southern flank of the system. So that's another sign that this is in a good environment for continued development, organization, intensification. So satellite imagery really looking promising for this to continue organizing and strengthening over the next 12 to 24 hours.
But it's a very large envelope of energy. How does that get factored in to everything? Where a lot has been made about how large this tropical wave was when it came off Africa and still is. Is that the reason, part of the reason why this is taking longer to develop, do you think? Harder to bring it all together.
Absolutely true. So when you have all of this, when you have the wave that's, this is well over 1,000 kilometers across.
Wow.
Several hundred miles, nearly 1,000 miles from the northern coast of South America all the way up into the central tropical Atlantic here. Hundreds of miles east of the northern Lesser Antilles. So yes, this is a very big wave. It's a very broad circulation. And the challenge for a storm developing in this context is to consolidate, to go back to physics, you may remember from a long time ago, or
right.
Not a long time ago, depending on who's watching.
Right.
We're really looking at angular momentum here, right? So the circulation has a certain amount of angular momentum associated with it. And when that angular momentum is distributed across such a broad area, you know that the velocity at any given point is going to be relatively low.
Right.
So you have all this energy basically that's distributed over this vast swath of the ocean, and the trick is to consolidate it. And you know the classic example is the ice skater twirling on the ice, and they bring their arms closer to their bodies, and then they speed up. And that's basically what PTC9 is trying to accomplish right now. It's got its arms outstretched, sort of quote unquote here, with this large band of convection way off to the northeast, and then another one way off to the southwest of its center. And it needs to bring all of that closer to where it's trying to consolidate here near Barbados before its winds can ramp up and close off a center of circulation. And
Makes
we can call
sense.
this thing
Right.
Tropical storm.
Gotcha. Yeah, and that's called the conservation of angular momentum when it starts to do that. And it really, physics and fluid dynamics, it's all fascinating. And that skater analogy is something we talk about a lot. So a broad area, a lot of ocean, a lot of energy to try to focus. And I talk about that on the Vorticity signature charts that I show you from the University of Wisconsin. When it's broad and stretched out, you know, it's still got a ways to go. But when it's nice and bundled, the more round our weather systems are, typically the more powerful they are on this planet and probably most other planets. Very good. All right, so what's next?
All right, so the next challenge is we have to figure out where this thing is headed in the next, say, 2 to 3 days.
Sure.
Right, because it's facing the prospect of moving onshore in the Dominican Republic here, or Puerto Rico. And you notice, I bring the Google Maps topo terrain up here because you can see that these mountains or these islands are quite mountainous.
Yeah.
Some of these peaks extend over 10,000 feet. And what this will do is basically shred any circulation that we've developed. And if the cyclone moves over these islands, they're basically going to go right through the shredder. So our next challenge in the forecast perspective is figuring out, does this system get shredded by these islands, or is it able to make it to the other side relatively unimpeded?
Sounds familiar.
To do that,
like.
Yeah, right. This is a problem we face all the time.
Right. Just a year ago, plus 1 month, Dorian, we were almost certain, it's probably going to go across the eastern part of Hispaniola. And not only did it not do that, but it even sidestepped Puerto Rico. Story for another day. We're going to cover that in episode 5 of my new series, The Hurricane Highway. Talk about that later. But yes, we have actually gone down this path before. So, where it could go, and then, how strong could it be? That's the next part.
Well, to answer question number 1, unfortunately, we have to answer question number 2 first.
Sure.
And the frustrating thing about the forecast for PTC9 is that its track forecast is unusually sensitive to its intensity forecast.
Oh, wow, okay.
So what do I mean by that? Well, to figure out where this thing is going, we first need to figure out how strong it will be.
Right.
And to explain that, I'm going to show you the wind pattern at 3 different altitudes. This is the lower level winds at right around 5,000 feet above the ocean.
Okay.
And don't focus on the circulation associated with the system. We're going to try to squint our eyes and sort of blur that out. And when you do, you get a map that looks something like this, where you have this ridge axis that extends from Texas across Florida and to just south of Bermuda. Right. And the center of this ridge, or the center of this high pressure area, is located basically due south of Bermuda. That's this clockwise circulation up here.
Right here.
And when the ridge is centered just north, basically due north of the storm, the steering flow in the low levels is basically from west to east. So the key idea here is that the stronger a storm gets, the more it's able to, quote-unquote, feel steering influences higher in the atmosphere. So if it remains weak, it's only going to be able to feel this ridge here off to its north. And that means it's going to slide right west into Hispaniola and likely remain either an open wave or dissipate, or if this thing does become a tropical storm tonight or tomorrow, it would then weaken or fall apart over Hispaniola. So the weaker storm is only feeling the winds in the lower part of the atmosphere and is tending to move farther to the west, which would put it on a track on the southern side of the envelope, or the range of possible outcomes here.
Okay, makes sense.
If it were to strengthen a little bit more, it would start to feel the winds at about 500 millibars, which is about 17 or 18,000 feet. And here you notice some subtle differences, but they're really important with regards to the location of the ridge. So this is the ridge that we've been talking about. It's the Subtropical Ridge, the Bermuda Ridge, Bermuda Azores Ridge, whatever you want to call it. And this is basically the central feature steering the storm at this point in its life cycle. So right here in the low levels, it's centered just south of Bermuda. Here in the mid levels, it's centered east-southeast of Bermuda. And that's a really important difference because as this ridge moves farther off to the east relative to our storm, the steering flow is going to acquire more of a southerly component, which is going to push the storm farther north. So if this were to intensify into, say, a mid-range or strong tropical storm with max winds of 60 to 70 miles an hour, it would start to feel the influence of this high in the mid-levels a little bit more, and that would tend to push it a little bit farther to the north. So it would still be moving over Puerto Rico by that point, barring some weird convective circulation redevelopment that we saw with Dorian. But that is essentially a random process that's impossible to predict until it happens.
Now listen, real quick, so let me jump in, interrupt you. I know the Zoom thing makes it harder to do that. So one of the things to keep in mind, what Jack's talking about is not just that the wind 60, 70 miles per hour, therefore it's going to go more north. As the reason it would do that is because the convection, the thunderstorms would be more pronounced. And so the storm kind of fills out a little more. And if it's doing that, then it is likely going to be stronger. So the reason the winds would be 60 to 70 miles per hour is because you would have a convectively deep storm in the atmosphere filling into the atmosphere, thus feeling this steering layer more so than a storm that is more convectively challenged, that's not filling itself out into that atmosphere. That's how that correlates. Just wanted to jump in there. I'm done.
Yeah, absolutely. You're totally right about that. There's another little nuance there, which is that the thunderstorms they're always going to the top of the atmosphere, even now. It's the pressure. We talk about the low pressure inside the hurricane. That low pressure area will extend higher or lower in the atmosphere, depending on how robust the convective activity is. So you're absolutely right. I'm just using the winds as a sort of proxy to say, because that's more easily trackable. Yeah. So great for bringing that up. You're totally right. It's not the surface winds that are actually dictating this. It's the depth of the pressure perturbation. So anyways, if this becomes a little bit stronger of a storm, it's headed north, it might skirt the northern coastline of the Dominican Republic. But if we go back here to our Google Maps, you'll notice this is not the part of the island where the tallest mountains are, right? So you can imagine a track right over here along the northern coast. There's some hills to deal with here. It certainly won't help the storm intensify, but it's not the sort of circulation shredding towering mountains that we have over here in central Hispaniola or eastern Hispaniola, parts of Haiti. So that's why, even if we see a landfall down here in the eastern Dominican Republic or perhaps the northeastern Dominican Republic, that's not game over for the storm. Game over is farther to the south. So if this were to somehow rapidly intensify into a stronger hurricane, then you notice that the steering flow, this is really high in the atmosphere, about 30,000 to 35,000 feet. The ridge is now all the way over here, basically due east of the system, and that would push the system basically northwest. That would send it north of Puerto Rico or east of Puerto Rico. That is not currently what we're expecting. I think if I were to put betting odds on this, I'd say maybe 5 to 10% chance that this happens. But the point is basically to illustrate the continuum of, as the storm gets stronger, the steering flow will tip it farther and farther to the north. So it's a sort of continuous gradient there. That the stronger this is able to get, the farther north it's going to go.
And that can ebb and flow. It's not completely determined that if it's strong now, this happens. It could be strong, then maybe die a little bit. So it's stair steps. It's very complicated. But on the whole, a larger, stronger system will tend to go more north. And there's a lot of in-betweens too, as you know. It's very complicated. There's no easy answer.
Yep, for sure. And another complicating factor is that as this moves to the north of Puerto Rico and to the north of Hispaniola, you're going to get, remember that the winds around a tropical cyclone are circulating counterclockwise. So if you have a storm over here just to the north of Hispaniola, you're going to get southwesterly winds blowing into the storm's southern side. And what happens to winds that come off of the high mountains? Well, they drop down in elevation, they compress, they warm, they dry out. So that downsloping is going to basically inject some dry air into the circulation, even if it remains over water. So this, it could be, and it likely will be, negatively impacted by the islands of Hispaniola, even if it remains several hundred miles away from the actual summits.
Yep.
All right, so the next challenge, so this is sort of one of our forks in the road, and we've been talking about forks in the road with regards to the system.
You do well with that. Yes.
So basically, the first fork in the road is, does the system move from where it is now, east of Barbados, into Hispaniola or south of Hispaniola, or does it emerge into the southwestern Atlantic near the Turks and Caicos? So if it takes that southern track, we're basically going to be watching this as a tropical wave as it drifts across Cuba and then into the Gulf of Mexico.
Right.
And who on earth knows what will happen once it emerges into the Gulf of Mexico. Because this wave is so large and it has so much angular momentum, this isn't going to just fizzle out and go away like Gonzalo did.
Right.
So Gonzalo was a very small storm. We saw it encounter some hardship, and then it basically poofed.
Right.
That's not going to happen with this system. So we could absolutely see this follow that weaker southern track and then become a problem once it emerges into the Gulf of Mexico later.
Very good point.
For the sake of the rest of the discussion, we'll focus on the possibility that it emerges north of Hispaniola into this area. And at that point, it's going to encounter its next challenge. And its next challenge is going to be wind shear associated with what we call a potential vorticity streamer. So the only thing you need to know about this potential vorticity streamer, which sounds very complicated, is that it's basically a pool of cool and dry air in the upper levels. It's air that comes down out of the stratosphere over the mid-latitudes, and it basically is taking a detour into the tropics later this week. And we see that basically manifesting itself as this trough axis in the upper levels, extending from Bermuda down towards the central Bahamas, and then over into the southern Gulf of Mexico.
All right.
And ahead of that trough axis, we have this area of extreme southwesterly wind shear. So we're talking like over 50 to 60 knots, which is going to rip apart any tropical storm that comes into its sort of zone of control here.
Sure.
And that's exactly where PTC9 would be headed if it emerges north of the islands. So if the storm were to remain relatively weak, if it were to be challenged, say, by some dry air intrusions off of Hispaniola, it is going to have a really hard time making it through this wall of wind shear. And a lot of the guidance that basically kills the storm off, even though it doesn't move directly over the mountains of Hispaniola, one example being the 12Z run of the ECMWF model, it basically kills off the storm here in the Turks and Caicos because of this wall of wind shear.
Okay, makes sense.
So one caveat to that is that a stronger storm can basically build mount a defense against the shear.
Right.
And that comes in the form of its upper level outflow. So back on the satellite imagery, you can see this cirrus, fanning out in the upper levels. This is warm, moist, tropical air that's streaming away from the center in the upper levels. And remember that I said the PV streamer is this pocket of cool and dry air. Well, this upper level outflow from a tropical cyclone can actually bust a hole right through these PV streamers. And we saw that most notably in the past with Hurricane Irma. As it was crossing the Atlantic, and then Hurricane Florence did this too. It was crossing the Atlantic, a PV streamer got in its way, and then it basically blasted a hole right through.
Wow.
And there's the outside possibility that PTC9 could basically do the same thing by carving out and in this little envelope, and I've sort of drawn a cartoon version of what it might look like in this blue line, this little envelope of low shear.
Sure.
And then it can actually, and it's really cool when this happens, although not for those in the path, is that sometimes you'll bust a hole through this PV streamer, and then you'll break it into two parts, and then the two parts each help ventilate the storm in the upper levels, allowing it to rapidly intensify.
That is
and
incredible.
This is functionally what Dorian did east of the Bahamas. It blasted a hole through this PV streamer, and then it had two engines that was then co-opted those upper level lows and used them to help intensify. So the door is really open to that possibility only if this is a hurricane north of Puerto Rico.
So what doesn't kill it could definitely make it stronger.
No chance.
Right. What doesn't kill it could make it stronger. Interesting. All right. Wow, that'll be...
Yeah.
This is why we have Jack on here, folks. I'm telling you. All right. This is it. So what's next?
So the next question is basically, if it follows this northern path, it's going to emerge into the Bahamas either as a strong hurricane having blasted through this PV streamer, or as a weak tropical storm, or perhaps even a tropical wave having been shredded to pieces by this PV streamer. So what happens after that? Well, to answer that question, let's take a look at the synoptic environment. And now we're going back to this is the European ensembles. It'll be easier to show it here rather than in a static graphic. But basically, this is the signature of PTC9. It's this area of lower heights. Think of this as the upper level version of low pressure. Once it emerges in this area, wherever it happens to be, there's still plenty of ambiguity. Is it over here, having moved across Cuba as a tropical wave?
Right.
Is it over here in the Keys? Is it in the northern Bahamas? Those are all part of the range of possible outcomes.
Right.
But the important thing to note is that during this time, say Saturday and then into Sunday, this ridge is going to be really rebuilding near Bermuda. And then, meanwhile, a trough is going to be dropping down through the central U.S. And that means that there's basically only one way for this storm to go, and that is north and then northeast. And that's basically what's
so
forecast
familiar.
by most guidance at this point.
Right.
By the time we get to Monday afternoon, you can see this is a quote-unquote hurricane highway that extends from where PTC9 or whatever it ends up being, hurricane, tropical wave, tropical storm, who knows. But that hurricane highway begins down here in the Gulf of Mexico, Florida, northern Bahamas, rather, and it extends all the way up the East Coast. So whatever this is, and who knows what it'll be, there is really only one way for it to go, and that is some variation of up the East Coast.
Wow.
It's still possible that if this really becomes strong, it could sort of scrape the coastline, heading mostly out to sea or towards Nova Scotia. But we'll be tracking this up the East Coast, whether it's a nondescript batch of showers incorporated in a frontal boundary. Totally possible. Some areas get an inch of rain or so, and that's it. Whether it's a tropical storm and a few spots along the coast get some beach erosion, some heavy rain, some breezy winds, or whether it's a hurricane and we have a whole lot of other problems to talk about. Because of this strong ridge over here and this strong trough in the central U.S., there's really only one way for this to go. And that is highlighted in the EPS guidance here, where you can see, and I'll zoom in a little bit here, you can see that no matter where the EPS member, or individual ensemble member, suggests that the storm will be, basically along 25 north, this would be by this weekend, every single one of those possible outcomes turns it north and then northeast, north and then northeast, north and then northeast, regardless of strength, regardless of all that. So it's an interesting case where, despite all the uncertainty in the storm's track, in the near term, in the short term, in the medium term, by the time we get to the long term, it's up and out no matter what. So an interesting convergence of possible outcomes. We don't often see that where weather forecasts become more confident over time, but this is one of those rare instances given the confidence in that synoptic pattern.
And in this situation,
there's still plenty of details to be ironed out. But,
certainly, and one of those details is
from,
how strong? How strong will it be when it does that?
That's the $1 million question.
And maybe even the $1 billion question, literally. Wow.
Yeah, right.
Anything else, Jack? I mean, this is eye-opening.
Well, I mean, if you have other questions, there are plenty of nuances of this forecast that we could talk about for hours and hours and hours. But I think, honestly, at this point, the biggest question mark is what it does intensity-wise in the near term. And then past that, we've gone over the basic overview of where the question marks lie. And I think that's a useful exercise to do at this point, even though we don't know what will happen in the near term. But past saying, here's the general blueprint, I really don't think there's a ton of value in drilling into the nuances of exactly what this trough orientation might look like, or exactly what the environment will look like over the Bahamas, 4-ish days from now.
Right.
The biggest thing to do now is to focus on the satellite imagery, the recon observations, when this is able to develop a center of circulation, how strong it's able to get in the next 24 to 36 hours. That's really where my focus is at this point. And I think that's probably, focusing on those trends is going to give you the key to a lot of the later forecast problems that we're thinking about here. So
makes sense.
I'm definitely in watch and wait mode now, seeing how this develops.
Well, let's go back
to... The frustrating part is that how it develops is so random, right?
Right.
You know, we have these thunderstorms over here. They're popping up like popcorn. There's almost no rhyme or reason. The models are not designed to pick up on every one of these thunderstorm cells. Could they sort of interact with each other in a way that spins this up into a hurricane before Puerto Rico? Yeah, that's definitely in the range of possibilities. I don't think it's likely, but you know, what can you see in this map that rules that out? I don't think there's a whole lot.
Right.
Similarly, you know, there could be a sort of destructive interference, and these thunderstorms just wobble in the wrong direction and never really get going, and this ends up drifting south of Hispaniola as an open wave with nearly no convection. You know, again, not the most likely possibility, but certainly possible. So I think that, you know, there's not a whole lot else to say at this point other than we've outlined the sensitivity of the medium-term track forecast to the near-term intensity forecast, and we'll just watch to see how these thunderstorms evolve in the next 12 to 24 hours or so.
That's the key. Well, let's go back to where we can see you for a second. We're going to assume that, that this gets named, and one of our good friends down in Puerto Rico, his name is Carlos. He's trying to help me with this.
We're here in San Juan, Puerto Rico, and we are anxiously waiting for tropical storm Isaias. Isaias.
Why can't it just be Isaias? But it's not. Is what he says, Isaias. But I was wondering if you can just say Isaias, but no. So it's not a tropical storm yet. I asked him to pretend like it's a tropical storm and use it in a sentence. You know what I mean? So he said, we're in Puerto Rico anxiously awaiting tropical storm Isaias. So what do you think? Is it Isaias? Try it, Jack, from Maine.
I've heard, my best guess is Isaias.
There you go.
And the reason it's named that is because the WMO, the World Meteorological Organization, who's tasked with coming up with the list of names we use in the Atlantic Basin, and all the basins for that matter, they pick the names that are meant to be representative of the languages spoken in the basin
all around,
that's affected by these storms.
Right, they're not all going to be Bob and
our fair
Cindy.
share of easy to pronounce.
Right.
Yeah, we get our fair share of
Jack.
Like Dolly and Faye and Michael and all the English sounding names because the U.S. is of course often impacted by these storms, as is Canada and other English-speaking countries. But of course, our friends down to the south, mostly speaking Spanish, some Portuguese. So there are some names that are representative of those cultures as well. So we'll see. They can all make fun of us for mispronouncing Isaias over the next few days to possibly even a week or so.
Yeah, we're not doing it on purpose either. I take it seriously. It's just funny how people are going to have to deal with it, and it's going to create some challenges for sure. All right. Jack, I really appreciate this. We talked about a half an hour here. You don't get this on network television. It's not built for this kind of stuff, this kind of in-depth analysis. The power of the internet, the power of social media, it's amazing. And, this is on YouTube, and my site, my efforts are all supported by our crowdfunding group, the Patreon support, that make it so that I can do this as my job. Jack is going to go he's on his way to being a meteorologist, and a fine meteorologist at that. Hopefully this COVID thing can go away so he can get back into the classroom safely and finish up his studies, going to Cornell. That's where he's enrolled, if memory serves. Very talented individual there. Jack, thanks for joining me. I do appreciate it. Anything else you want to add before we sign off?
No, that's it. Thanks so much for having me, Mark. We'll, I'm sure, do this again at some point in the not-so-distant future, either with this storm or the next one.
Yeah, exactly.
There'll be plenty more.
We have a while to go, even after Isaias, or whatever it's called. I am Mark Sudduth, HurricaneTrack.com. Thanks, as always, for tuning in. I'll be back with much more for you starting tomorrow.